Hey everybody, welcome to another Calculus 1 video. Today we are going to be in section 3.4, but before we do that I want you to remember back into section 3.3 when we had a sum or a difference of two functions. How did we handle this? We simply took the derivative of each piece and added them together. Okay, so that's when you add or subtract them. So my question for you to think about is, when you have two functions that are multiplied together, how do we handle that? Okay, so let me give you an example. Let's take the derivative with respect to x of x squared plus 1 times 2x minus 3. Okay, well, if we use this same rule, f prime plus g prime, if we did f prime times g prime, the derivative of x squared plus 1 is 2x, and the derivative of 2x minus 3 is 2, and so you would get 4x. And maybe that's right, maybe that's not, but I can tell you another way to check, and the way to check is to FOIL this out first. So let's FOIL this out. If we FOIL this out, we get x squared times 2x, which is 2x cubed. And then we get negative 3x squared, and we get plus 2x, and we get minus 3. And so if I take that derivative, I get 8x squared minus 6x plus 2, which is nowhere close to 4x. That's not anything close to that at all. So what's going on here? Well, remember what the derivative does. It talks about change. And so because the derivative is talking about change, when you're adding, you add one change to the other. But when you're multiplying, these guys affect each other. The way that x squared plus 1 is changing is affected by the fact that it's multiplied by 2x minus 3. Think about the constant rule, right? If the derivative of x squared is 2x, then the derivative of 3x squared is 3 times 2x, because it's tripled the change. And so these guys are multiplying to each other. They're affecting each other. And that's what's going on here, okay? Well, that brings us then to the product rule. And the product rule says this: if you take the derivative of two things multiplied together, f times g, then what you do is you take the derivative of the first one and multiply it by the second. And you take the derivative of the second one and multiply it by the first, and then you add them together. That's the total change, right? Because as f is changing, that affects g. As g is changing, that affects f. And so f prime is multiplied by g, f is multiplied by g prime, and you can lay it out like that. Okay? Some textbooks may teach it like this, that you have a first and a second function, big F and big S. And if they do, that's fine. And so then you get big F prime S of x plus f s prime of x, first and second, right? Same idea, and the order doesn't matter because it's multiplying and because it's adding, so order doesn't matter. So how do we handle this? A problem like take the derivative of x squared times e to the x. Well, according to this, what do? You take the derivative of the first term and multiply it by the second. You take the first term and multiply by the derivative of the second if you're using these notations, right? And then that means you get what? 2x e to the x plus x squared, and the derivative of e to the x is e to the x. And so you get that total thing here as your derivative for this product, x squared times e to the x. And a second way you could do it would be if you wrote big F of x as x squared and big S of x as e to the x, and then you found the derivatives as 2x and e to the x, then you can just plug them into this formula that you've got right here, this f prime s, fs prime. You can just plug it in and you see how that would work. 2x e to the x, these two multiplied together, plus these two multiplied together, x squared e to the x. You get the same thing. Okay? So however you want to think about it, there's a couple of different methods of trying it out. Why don't you guys pause the video and you try this one. Don't FOIL it out. You can FOIL it out to check yourself, but let's try it using this term as my first function and this one as my second function and see what you get. Pause the video and come back and check it out. Okay, so once again, if we let our first term be called big F and we get x squared plus 9, and our second term be big S and that's 7x minus 15, then f prime is just 2x plus 0, right? And s prime is just 7 minus 0. And so if our derivative rule is f prime of x times s of x plus f of x times s prime of x, you've got to memorize that formula. I won't give it to you, but then again, for this semester you have your notes allowed, and so you do it however you want. But anyway, so we get 2x times the group 7x minus 15, don't forget to group it, and then the group f of x, which is x squared plus 9, times s prime, which is 7. And again, I am okay with you leaving it like this. My math lab is going to expect you to simplify a little bit further, but you just distribute that and combine like terms, and that's fine. But I won't ask you to do that on the quiz. Okay, I will not ask you to do that on the quiz. Okay, so that's how you handle a product. Well, if you handle products that way, then you probably have to handle quotients a different way also. And so we do have a quotient rule. Here we have a top function and a bottom function. And so if we're going to write out the formula in a slightly different method where we have top over bottom instead of just f and g, then we get the bottom function times the derivative of the top, according to this, minus the top function times the derivative of the bottom, and then the entire bottom gets squared. Now be careful when you do this, guys, because the order matters now, because this is a minus. So you've got to get bottom first, top second, and do it like that. So if we follow this rule, we take the bottom times the derivative of the top. The derivative of the top is 3x squared plus 2. Again, if you prefer to write them out in small functions over here, then do that. I'm just kind of going about it the most direct route. Okay, so this is bottom times the derivative of the top. Now you take the top as it is, x cubed plus 2x, times the derivative of the bottom. The bottom derivative is just 2x plus 0. And then that's over the entire bottom squared. Do not cancel out this x squared plus 8. You're not allowed to do that. This is not a factor of the numerator. If you wanted to simplify this, you would not square out the bottom at all. You would simply FOIL out the tops and then combine like terms. But again, I don't expect that from you on my quizzes and worksheets and stuff like that. But you should certainly be able to do it, right? But in a timed environment, I'm not going to ask you to do that. Okay. So that's the quotient rule. Make sure you write it down. Make sure you learn it. Make a flashcard, whatever you need to do. I have found the easiest way to do this is if I write down this formula first every single time, or this formula here, or something similar to it. If I write it down every time I do a problem in my notebook, then by the time I'm done 20 problems, I've got it memorized. It's stuck in my head. And so that's what I would recommend. You want it to be as accessible as possible. If not, at least make a flashcard with it on it or something so you can reference it quickly. You guys try this one. E to the x over x squared plus 21x. Find the derivative of that. Pause the video, come back and check your answer. Okay, so let's take a look at f prime. The rule is you want to do the bottom times the derivative of the top. The top is e to the x, so its derivative is e to the x. Minus the top times the derivative of the bottom. The bottom is x squared plus 21x. The derivative is 2x plus 21. All of that over x squared plus 21 all squared. I will show you, that's the derivative, you're done right there. Now I will show you a little bit more algebra here, because in this case, with e to the x running around, we can factor out an e to the x and make simplification much easier. If I factor that out, I'm left with x squared plus 21x, and then minus the group 2x plus 21, And so I can simplify the numerator even more by distributing this negative and combining like terms. So we get e to the x times the group x squared. 21x minus 2x is plus 19x minus a 21. And then that's all over x squared plus 21 all x all squared. These are all x's. I missed the x there for a second. Make sure you copy things down correctly, obviously. I wasn't quite paying attention well enough there. So the bottom is 21x, x squared plus 21x. So that should be in the bottom squared, x squared plus 21x. And that nothing there simplifies to simplify up top or anything like that. So that's as simple as you can get it. Okay. Now one more problem to try on your own, because this one's a little bit more tricky, because here you have a product in the numerator and you also have a denominator. These rules we are learning will have to be eventually, and here's an example of it, they will eventually go together. They will go in tandem. You'll have to use more than one rule. And so understanding the rules well enough to know when to use what rule is very important. So with that little bit of a background, that little bit of a hint, try this one. If you don't get it, no big, but I will work through it here with you momentarily. Hit pause and give it a shot. Okay, so to accentuate what's going on here, I'm going to break it up this time. T of x is the entire numerator. X cubed times 3x. Excuse me, x cubed times e to the x. Numerator, denominator. B is the denominator, x to the fourth minus 11x squared. All right? So when I go to take the derivative of the top, which is part of my quotient rule, the derivative of the top, what do I have in the top? I have a product, which means I have to do the product rule. Derivative of the first times the second plus the first times the derivative of the second. So see, inside of the quotient rule, I'm doing the product rule because there's a product in my numerator. And that's where I got all that. The denominator's easy, 4x cubed minus 22x to the first. And now when I go to find the derivative, I'm going to follow my formula, t prime of x b of x minus b prime of x t of x all over b squared. So let's plug in. T prime is all this stuff. You got to group it. Parentheses are huge, guys. Missing parentheses will absolutely kill you. If you have parentheses that are missing, you will miss the problem, because there's a big difference between 2 times x plus 3 and 2 times the group x plus 3. It's a total difference, right? So if you're missing parentheses somewhere, you will lose points, possibly miss the whole problem, right? So sorry, so this is the top, t prime, all that stuff in parentheses, times the bottom, which is x to the fourth minus 11x squared, minus the derivative of the top, which is 4x cubed minus 22x, times the numerator, which is x cubed e to the x. And then all that big, huge, ugly mess is over the bottom squared, x to the fourth minus 11x squared, all squared. Don't try to simplify anything here. This is not simplifiable. You could FOIL everybody out and simplify the numerator a little bit, but it's not worth it. So just leave the answer like that. I'm totally good with that. And you're good to go. All right, so this is we're hitting the skills portion of chapter 3. For skills, there's nothing better than just trying it over and over and over again. Do lots and lots of problems, and you have lots and lots of problems to practice in my math lab as well as in the worksheets in D2L. So knock it out. As always, reach out to me if you're stuck on something, and we'll see you later. Thanks.